I think a small amount of refactoring is in order. What I think we should do is have the game mode class, the game mode blueprint, be in control of basically all of the game logic. That way we have one central access point to modify any variables and behavior that we want to change as we progress. So I'm going to go to the grid blueprint and actually change all of these variables to be read from the game mode actor, so that those variables are, in one place for all other actors to access. So let's go ahead and change all these variables to become game mode owned. So I'm just going to go to the game mode and create these variables again. Now the reason I decided to do this is because I want the game mode to control all the logic, so to spawn in the blocks, we want to have the game mode use these variables too, so it might as well own them, and then the grid can just read them from the game mode itself. That might seem a little bit counterintuitive, but I think the grid is dependent on the game mode. So the game mode is like the master that holds all the cards, and the grid will just read from those instead of using its own variables. So in order to do that, we're going to need to go to the constructor, the construction script rather, and before we add the columns and queues, we need to get a reference to the game mode. We could set that as a variable. I don't think we'll use it again, but let's go ahead and do that now anyway. So I'm just going to call this game mode. You could call it game mode ref or game mode reference. I'll just call it game mode. We need to change the type to the actual type of this game mode blueprint. Make sure it's the correct one, the LPP game mode underscore blueprint. And then what we're going to do is use this function here called get game mode, which gets the general game mode that's currently active. And then we will cast it to our specific type, so we can reference this type's variables. And it should always be successful because we're only going to ever have that one game mode. And we'll set this as set our game mode function, which happens to be called game mode, to the result of this cast. And now we have this variable that we can use to read its values within these collapsed functions here. So this will make this a little bit messier, but not, it's going to be worth it. So I'm stretching out to give myself a bit more room here. And now we're going to get the game mode, and then on the get the game mode, read the game mode's horizontal offset. So we're just replacing this call to our horizontal offset with the game mode's horizontal offset, and we're going to be deleting all of these four variables in a moment here. So same thing here, we want to get the num rows from game mode. Now we verify that the grid still looks the same, which it does not. Now there is an unfortunate side effect to moving all of these variables into the game mode from the grid, and that is they're no longer available at construction time. So if you look here at the viewport, the grid is no longer previewing properly. It's not there at all, because what's happening is it's trying to find the current game mode, but the game isn't running, so it will fail this cast. And that is the case for any pre-placed grid elements. Like here we pre-placed an instance of the grid actor, so it's going to not be able to spawn in those values because it's like, oh, it doesn't work. I can't find a game mode. It's returning null. So what we can do to fix that is, now hang with me, I'm going to come up with a workaround for previewing it before the game starts too, but for now, to have it work properly, we want to spawn in the grid BP instance from the game mode. So at begin play, we can call spawn actor from class, and then select the game mode or the grid underscore BP class. And for the transform, we've already discussed why we want it to be just 0, 0, 0. So we can type make transform, and the default values are just a default 0, 0 for rotation and location with a 1, 1, 1 scale. So we'll go ahead and use that. And this will spawn in our grid when the game begins, which is perfectly fine. It'll, for the player, it's going to be exactly the same as before. See, the grid spawns in properly, but when we're not playing, the grid is no longer there. So as a like a developer only workaround, what we can do is leave these variables in and call them like default. Actually, no, that's not going to work. So let's leave these in like that. And then if the game mode if the game mode does exist, what we'll do is set our local variables to the game mode's variables. So I'll go ahead and pull these 4 out and set them to, because these are the only subset of values from the game mode that we currently care about, so we can have our own local versions of them. And if the cast was successful, we will set our local copies to the ones from the game mode. Get vertical offset. In a moment you'll see why I'm doing this. I can go ahead and explain now. I'm going to go ahead and finish this first before I explain it. So if the game is running properly and we are successfully able to find the game mode, we're going to set our local copies to the game mode's values. This will ensure that changes we make in the game mode will propagate in the real running version of the game. But if the game is not running, then instead of setting these values, it's going to just bypass this logic right here. So I'll go ahead and move this up. Bear with me, this will make sense in a moment. So if the cast was successful, then we're going to go ahead and use those new values. And if the cast failed, which means the game is not running right now, it's in editor mode, then we're going to follow along this path, which just bypasses those updates and leaves these at their default values. And that means they'll use the values that we set here explicitly in the editor. So now that cast fails and the editor values get set, but this is incorrect because I haven't reverted the logic here. So, unfortunately, I'll have to change these, so I'm going to edit the video so you don't have to do this incorrectly. And now, finally, thankfully, we have the grid showing up properly in the editor. But what we can do is call this like test grid. And we can make this, can we make this specific instance not appear in game? Yes. So now this is only in the, I'm going to call it editor test grid. So this is a grid we see when we're in the editor, but if we were to play the game, you can eject and you'll see that this grid that we're looking at right here is actually the grid that was spawned at runtime. That's why it's yellow here, as opposed to this one is white, and this one is actually not visible. It is hidden, so the player will not know anything about that one. It looks the same regardless, and it's not affecting performance in any way. And we can delete this grid before we, ship the game if we get to that point. But that way we have the values updating from one source of truth, which is the game mode, and if we need to make changes to the game mode, they'll propagate automatically, but we can test the changes in the editor by using these local values. For clarity, while the videos are, in progress, I think it's safest to have the grid visible during the editor too, just for debugging purposes. So that was fun. So now that the game mode has its own variables to use for the offsets, we can spawn in the player's quad of blocks. And for now, we will... Okay, so I think I'm going to preemptively set up the quad in variable form here. So I'm going to say, this might not make sense for now, but I'm going to call this quad TL. And what I mean by that is quad top left, as in if you're looking at the quad of blocks from that previous image, or from, pretend this 2x2 block here is the player's blocks, and the top left block is, the second quadrant, this one right here. So this is top right, top left, and bottom right. And what these are going to be, they're each going to be references to a block BP object. So I'm going to make 4 of these quad TR, quad BL, and quad BR. Now there's, countless ways you could structure this type of functionality, but what I'm doing is the game mode is in control of these 4 quads, or it stores the references to them, and the player controller is going to receive the input command from the player and then tell these 4 blocks to move left or right, or to rotate around each other according to which input was selected. So that might not make any sense. Maybe these should go in the player controller. We'll find out how it presents itself in the future. But for now, we're going to use the player controller to get the input commands. So let's type in, move left, and this is an action event that when as it says here in the tooltip, when move left is pressed, whether it's keyboard or gamepad, this will execute, and we will tell our quad to move left. First, let's get the game mode. Let's do that at begin play. We could do this in the constructor too, just for consistency. Of course, every Blueprint actor needs its own reference to the game mode object. So, ta-da. I'm casting it to the incorrect type. There we go. This cast should never fail, whether it's in the editor or not, because the player controller is also spawned at runtime. So the game mode will spawn the player controller, and the player controller will then get the game mode as it spawns. So when move left is pressed, we're going to get a reference to the game mode and get quad. We'll have to do all 4 of these, I guess the order is not important for movement. It may be important for rotation depending on how we implement that. But so now we just set the location, set actor location. And we will get actor location. We'll go ahead and break this and use the floats. So the game mode has the horizontal offset value, which is what we'll be changing our position by in order to get the new value after movement. Now some crossed wires are going to be inevitable in this situation, but it shouldn't be too bad. There's always ways to restructure things to minimize overlaps, but it's not always completely avoidable. So I try to use these reroute nodes whenever I can to clarify things visually. So when we're moving left or right, we're only going to change the x component of our position, and the other 2 will stay the same. So obviously we have to repeat this for all 4 of the quads. All 4 blocks within the quad. Each quad has 4 blocks in it. And to prevent a nasty spaghetti of having 4 of these, I think what we can do is have we could have a for loop, or sorry, a for each loop that gets the 4 quads, the 4 quad elements. You know what? Let's think about this for a moment. We definitely do want to have some sort of for each loop so we don't have to replicate this 4 times for each of the input possibilities, and in the future that's going to just create a huge sprawling blueprint. So what we should do is create an array for the purposes of movement and stuff that will always have the current references to the quads contained within it. And let's change this to get quad elements. Returns a 4 element array with all references to array of references to all the quad blocks used in situations where the same action is being performed on each of the 4 blocks. I think that is hopefully self-explanatory. This function exists solely to minimize redundancy in the blueprint construction. And in cases where we need to do the same thing to all 4, we have an easy way to do that, so we can loop through all 4 of them without having to duplicate this literal thing 4 times and change this each time. We can instead just make this into a variable and loop through it 4 times using a for each array. Sorry, a for each loop. So hopefully that makes sense. I'll show you right now. I'll make that for each loop, and we'll end this video there, and hopefully that makes sense. Well, first we'll prove that it works by moving the block to the left. So I'll just do a for each loop. So when the player presses the left key, we're going to get our reference to game mode, and we're going to call the get quad elements function. But right now it does not return anything because I didn't update this. So we just need to make array. Same things before with putting the 4 elements into the array. And then we're just going to return as an output quad array. It's a reference, it's an array of block blueprint references. So you have to click this and turn it into an array. And now just set that as the output. So it's like a little helper function that just consolidates the 4 current quads into an array. And then the player controller calls that function and gets the result, which is that array of the 4 elements. Now for each element in that array, we're going to remove this for a moment. We still need the game mode reference here. But instead of using the game mode's reference to a specific block, we're just going to use the current quad element and set that position and get that position. So there we go. So now this loop will run 4 times, and each time it'll get one of the 4 blocks and move it the proper distance. And on complete, we don't need to do anything right now, so we'll just leave that blank and then recompile, and that should work properly. Of course, we're not yet spawning in any blocks at all, so we'll go ahead and spawn in the quad. Now in Lumines, the quad appears pretty much as if there were an imagine 2 more invisible rows of this grid. The quad would spawn like in the center here, directly above the top row, to give you a chance to like move your quad before it enters the playing area itself. So to spawn up there, we just need to, multiply by the proper amounts to get to there, and then spawn our quad in there. Now, obviously, there's some fine details, like the quad itself isn't an object. It's it's a variable. So we spawn the quad in somewhere based on a central position, and then spawn in the 4 elements like that, or do we start with top left and then spawn in the other ones according to where the top left is situated, or bottom left? If we want to keep this, bottom left as the origin approach, we would have the bottom left tile of the quad spawn in. We'd set that as like the origin point, spawn it in, and then spawn the other ones relative to that. I guess we'll go with that. If that didn't make any sense, again, hopefully it'll make sense in a moment once I show you what I'm talking about. So we will make a function in the game mode that will have it spawn in our quad. So we'll just call it spawn new quad, and the location can probably be hard coded in there because it shouldn't really ever change. Obviously it'd be better to parameterize it and have a default. Maybe we'll do that, but for now I'm just gonna hard code it in. So as I was saying, we want it to spawn in here, so we're gonna have the origin, quote unquote, of the quad be the bottom left, the center of the bottom left tile or block. So we'll spawn in the block right here. Oh, by the way, I'm probably going to squish the blocks down into tiles shapes, otherwise they might look a bit weird. But then again, because it is an orthographic projection, it may be indistinguishable. So maybe we will leave them as blocks, but for now we'll just call them blocks. Anyway, we'll put the bottom left block here, and then 1 horizontal offset for the bottom right, 1 vertical offset for the top left, and then the top right is both 1 vertical and horizontal offset. So to find the coordinates for this spot, we need to remember that the origin and our offsets have all been aligned to the grid lines themselves, but we want the centers of the squares formed by the grid, right? So we need to actually go over by 1, 2, 3, 4, 5, 6, 7, 8 offsets. But actually not 8, we want 7.5 because we want to be here in the grid. So let's keep that in mind, and first we'll spawn in the bottom left block by, let's spawn actor from class. And the transform, we'll just say make transform. And set the location to be based on, we'll do a parameter type thing, we'll do a dynamic. So since it's 1/2 minus a half, right, because it's 7.5 columns over is where we want the center of our block to be. So that's going to be half of the number of columns. And then minus 1/2, right? So that we are at 7.5 for now. And times this by the horizontal offset. And of course this is relative to the grid. So we don't want to hard code this as where it happens to be right now. We can, and it should work fine, but we want it to be relative to the bottom left of the grid. So as long as we don't move the grid, this will be fine, but we're just inviting trouble down the road if we need to move the grid for some reason. I don't foresee us ever needing to do that, so I'm going to hard code this. Like for now it's semi-hard coded, semi-dynamic, but it should be fine because I don't think we're going to move the grid, because that will probably involve rewriting some of the grid generation code. So for now we'll just leave it like this. So this should be 750 units, but we'll make sure that works in a moment. And then Y and Z, well, Z, we need to do something similar here. We need to do all of the rows plus 1, plus 1/2, right? So now let's look at the rows. We start here, that's 0 offset, and then 10 offsets should take us to the top here. But then we want to go 1/2 of a row up. So that'll be very similar to this, but not. So instead of num columns, it's num rows. And instead of dividing by 2, we're going to add 1/2. And instead of a horizontal offset, we'll use the vertical, even though it's the same number for now. And Y is the same, 0. And that should spawn in the bottom right quad, so we will call this bottom left quad. So this new one we spawned in is our new bottom left part of the quad. And I guess for now I'll just see if that works at all. So before I add the other 3 blocks to it, let's just on begin play, after we spawn in the grid, let's spawn new quad. We'll probably move this somewhere else to a timer event, but for now let's just do that. And it does, ooh, it's very bright, but it does spawn in at the intended location, so that's good. Now let's go back to this function and duplicate this logic. Now I actually accidentally ignored my own instructions and hard-coded all 4 spawn locations in, but obviously that is not necessary because we can hard-code the spawn of one of the bottom left tile and then spawn the other ones relative to that. So that would be a much smaller blueprint and would require less maintenance because it would be much easier to change the locations of one by just changing one thing. So anyway, let's simplify that by now, once we spawn in the first one, which will be, hard-coded like this, the other spawns will be much simpler, or, a little bit simpler. Because we can just spawn in another block BP as we're already doing here. Set, for instance, top left. And the transform will be relative to the one that we just set, which is the bottom left. So now I can get bottom left. And we could break, I guess we'll just break them both, why not? Split this too, and that's going to be a lot of floats, but you know what, that's actually pretty bad. It's not going to be that much simpler, I guess, because we're going to have a bunch of green wires still, but it won't look much easier, but it will be easier to change just one of them instead of having to change all 4 later if we need to. So all we need to do here is add, actually this is the top left, so we need to add 1 offset, vertical offset to the Z component. And these can remain the same. Once I get this laid out for one, it will be just the same for the other 2. So again, all but one of the quad spawn locations are relative to, oh, this is good. So yeah, we just change this one and then we'll have all 4 of them automatically change. Go ahead and do the bottom right one, because, or top right one, because that will incorporate both of these things, both of the offsets. That's about as good as I can make it look. Might look a little bit complicated, but it's really pretty simple, I think, if you just say add one offset in both the X and Z axes. And then for the bottom right, we're just doing the X-axis. So that should be working properly. First I need to make sure these are the proper things, which they are not. Bottom left, this is top left, this is bottom right and top right. So this is bottom right and top right. Okay. So now it is there. It's cut off a little bit, so we'll have to move the camera. Let's go ahead and do that now, I suppose. I'm going to pull the camera, I'm going to widen the camera view by increasing this value. I don't know why I'm not seeing the editor grid here. I am seeing it. I don't know why I'm seeing it. Oh, yeah, I can see it in the editor, but not in the camera, because the camera is seeing the game view. So if I just turn this back on, or uncheck that, now we can see the grid again. Oh, yeah. Translating the camera doesn't matter in orthogonal. So I'm just going to increase that and then move it up a little bit. I should clarify that and say translating it along the y-axis does not increase the apparent size, because that's the whole point of orthogonal, is that it doesn't do that. So now we should be able to see that. There we go. That's probably a little better. Now we have room for score elements in the UI on the sides, but we'll fine tune that later. So now let's get the movement working, and we should be good to go. I'm pressing to the left, or I'm pressing A, and I'm moving to the right, so I have that backwards. So that's okay. We can fix that. So move left, get all the quad elements, and then translate them. Obviously I want this to be minus instead of plus. So I could invert this and feed it into a plus, or I could change this to a minus node. I think I'll go ahead and do that. Oops. So when we move left, we want to actually move left. And while we're here, let's go ahead and duplicate this for the move right and move down. And then we'll end this video. So now let's do the move right event. Which now this will be a plus. And then for the move down, I can't copy the event name. We just need to change the Z components instead of the X component, so we can just plug this in instead, move this to Z instead, get rid of this, move this down. And then move this over. Actually, we don't need those reroutes so much anymore. There we go. and it is minus so that it moves down. You can't move up in the game because that would defeat the whole time constraint element. Now you can see it works as intended. We got the movement for right, left, and down. No collisions yet, of course, and you can go off forever in either direction, go down through the bottom, but we'll work on that soon. So, cool, we got movement working and spawning working. Long way to go still, but at least we have the, the barest resemblance to the real game Lumines now, so cool, and I'll see you in the next video.